Hey everybody, today I'm going to continue with ideas from chapter 6. But before I get started with that, I just want to recap correlation. At the end of the last lecture, I asked you to come up with the correlation coefficient for St. Cloud and Phoenix. And I did that in the graph here, and we ended up with an R squared value of 0.02. And if you compare that to St. Cloud and Minneapolis with R squared of 0.976, you can see that this is much, much lower. What that's saying is that St. Cloud and Phoenix, the temperatures there are for a given day are very weakly correlated. And you would expect that because they are thousands of miles apart from each other, whereas St. Cloud and Minneapolis are quite close. So if a day is warm in St. Cloud, it's likely to be warm in Minneapolis. But if a day is warm in St. Cloud, that doesn't tell you too much about what it's likely to be in Phoenix. Okay, so moving on to chapter 6 now. The words that we're going to deal with today are center, measures of center, variation or standard deviation, distributions, and z-scores. So I'm going to start by calculating the average and the standard deviation for each of our three towns. The Excel command for average is equals average, left parenthesis, and then you want to select all of your data. All right, so the average temperature, average high temperature in March 2019 for St. Cloud was 33.48 degrees. Standard deviation, it's going to be equals ST DEV, and then we have to make a choice. You can say dot S for a sample or dot P for a population, and we're going to use the dot S, which is true anytime you're looking at a sampling of data. All right, again, select that data and you get a standard deviation of 14.2. I'll talk more about what that number means in a minute, but first I'm going to calculate the average and the standard deviation for Phoenix. All right, so average, I think you already know what that means. Here the average is 75.8 and here it is 33.5, so that tells you something about an average high temperature in March for each of the two cities. But let's spend a little more time on the standard deviation. So the standard deviation for St. Cloud is 14.2, and the standard deviation is 7.3 for Phoenix. And what that means is that in Phoenix, the temperatures do not vary as much. The high temperatures in March do not vary as much in Phoenix. The 7 degrees versus the 14 degrees in St. Cloud would say that there's much less variation in Phoenix. And if you look at the data bears that out because in St. Cloud, it can go all the way from a high of -5 to a high of, what was our top number there? 62, which is quite a wide range. And in Phoenix, here we'll go over to our frequency table, you can see most of the days are in the 70s and 80s. There's just not a lot of variation there. So this is putting a number to that. It's talking about how much variation there is in the data. All right, next, I want to make a frequency distribution, and I'm going to do a frequency distribution for St. Cloud. I'm going to take this table that I have up here, and I'll copy it and move it down below. And then I need to make a couple of changes. To do a frequency distribution, I need to just have a single number here instead of a range so that I can graph it using an XY scatter plot. So let me make a new column, call it temperature. And then instead of the frequency, I want a number between 0 and 1, which would be the relative frequency. All right, and for the temperature, I'm just going to pick the middle of each of these bins. So it go with -5, +5, 15, and so on. And for the relative frequency, remember there are 31 days in the month, so I'm going to choose equals 1 divided by 31, and then I'm going to change all of these to a percent. So there's a 3.2% chance that the temperature is in this range. I'm going to put, I guess that's okay. I'm just going to copy this down to the rest here. Yeah, and you can see that the highest frequency was 12, and that translates to a relative frequency of 38.7%. Okay, now I can grab this set of data, and I'm going to go to a XY scatter plot. And I'd like one that has lines in it, so I would choose this one. Yeah, that looks pretty good. I'm going to call this March 2019 St. Cloud high temps. And what this is doing is it's just giving you a visual representation of a frequency table. So you can say that most of the time the temperature is going to be in this range from, say, right here to right here, or in that 35 to 55 range. Now, if you look up in your book normal distribution, that's a really important term and an important idea for this chapter. And this is not a perfect normal distribution, but it's not too bad. In general, for a normal distribution, you want to see that there is one maximum point, which we have here, and then that things taper off as you go out to the tails. And we do get that. We get the tapering off at the tails, and we get the one maximum. It's not that perfect bell-shaped curve, but it's not too bad. All right, so now we can use this chart with our average and standard deviation to answer some questions. So our first question is, how likely is a high temperature of 35 degrees in March in St. Cloud? Well, based off of your chart here, you can say it's pretty likely, but let's use a formula to give us a data point there. So I'm going to use something called a z-score. And you can read the formula in your book, but we're going to take the data point minus the mean and then divide it by the standard deviation. So this is equal to, our data point would be 35 degrees. Subtract the mean, the average, and then divide by the standard deviation. So a high temperature of 35 degrees translates to a z-score of 0.107. And the way that z-scores work are that any z-score between -1 and +1 is very likely. And any z-score between -2 and +2 is quite likely. And as you get further away from 0, so less than -3 or greater than +3, then those values are increasingly less and less likely. So to answer our question here, because that z-score is between -1 and +1, we can say that a high temperature of 35 degrees in March in St. Cloud is very likely. Now let's do the same thing for Phoenix. Right away, looking at the frequency table for Phoenix up here, you can see that there were no days in 2019 that had a high temperature of 35 degrees. So just by that, we're going to say that it's pretty unlikely. But again, we'll use a z-score to give us a better idea. So to calculate the z-score, I'm going to say equals, again, I'll use that data point of 35 degrees. I'll subtract the average and divide by the standard deviation. And this gives me a z-score of negative 5.62. Now remember, I just said that any z-score that's less than negative 3 would be very unlikely. So that should be our answer here, very unlikely. All right, so you can read in your textbooks for more examples of z-scores and more examples of the normal distribution. And again, if you have any questions on any of this, please email me and let me know. Thank you.